All right, so the first assignment for us to go over right now is the Chapter 10 homework number 7, numbers 26 through 28. Wasn't very many questions, wasn't a whole lot for you to do, which, you know, of course, made me raise an eyebrow. Tends to be, let's see, which one do I raise better? I don't raise either of them very well. Maybe I raised my left one a little bit better than my right one. I raised that eyebrow because I wondered, well, if you only had 3 questions to do for homework and you had all of this time, maybe doing the review ahead of time, like Kevin did, like Genesis did, and like Kim did. Of course, Kim not only did the review, Kim also did the extra practice problems that were there. I threw an extra point at Kim for that. So just, you know, at some point in time when you notice the extra credit column, you might see an extra point sitting in that column. Just know that that's where it came from. Because, you know, doing the review before the review day is always a good idea. That way I can move quickly and we don't have to wait while people try to practice the problems. Like these ones here, I can move quickly through these because you already did them. So you're just checking my work versus your work and everything's good. An empirical formula for a substance was found to be Ch10. It has a molar mass of 60 grams per mole. What is the molecular formula? Okay, so they've already done the stuff that number 27 is going to do. So I'm going to do both of these questions at the same time. In question number 27, 39.7 grams of carbon. Remember that when we get into formulas like Ch4n, that's telling us the number of moles of each element that is present, not the number of grams of each element that's present. So we have to get out of the percentages. Now, how do you get out of a percentage? Well, the easiest thing to do is just assume, not with that though, let's put the you and me in there too. Assume 100 grams so that then we can say that each of those percentages is the number of grams. So 39.7 grams of carbon. Now I'll get out of grams of carbon, get into moles of carbon. Sorry, I'm just trying to, okay, good. A lot of you are not having any issues with your Zoom, so that's good to hear. If it does, well, I'll sign it. Right? I wish I could sign. What a great thing to learn how to do is to be able to do sign language. The chat keeps disappearing too. Once I touch the screen, it disappears on me. I haven't quite figured that one out yet, and when it stays and when it doesn't. Get out of grams of hydrogen. Get into moles of hydrogen. Periodic table says 1. And then lastly, get out of grams of chlorine and get into grams of chlorine. I know you're sitting there going, why is he doing question number 27 before he's doing question number 26? Because I need to prove a point to you of what's going on in question 26. So 39 points. One of you, but nobody in this, I don't see if the one of you that I am speaking of is here right now. This person doesn't always come to the Zooms, so therefore they might not be here. The person is not here, so I can't speak to that person, but I can speak to all of you. And that is, what do you do if your calculator stops working? You're in the middle of your test, you're in the middle of your homework assignment, all of a sudden you're like, oh crap, this thing just crapped out. What I would suggest is, number one, in class it's not an issue because I have loaner calculators. So if your calculator stops working, we have a loaner for you. If you forget your calculator, we charge you a quarter donation to like Key Club or Interact or something like that in order to borrow my calculator. But at home, you don't have that option. So my suggestion for you at home is find an online calculator. Obviously, I know a lot of you have a calculator app that's built into your phone. The issue with the calculator app on your phone is it's difficult to get into the scientific notation, and not that you need sine, cosine, and tangent, but some of that stuff's kind of difficult. But you can find online calculators that are actually the same calculator buttons as the one that you use for your regular calculator. Wouldn't it be a good idea to find that and bookmark it into your web browser? And then if something were to happen, or like, let's just say you're doing your homework and all of a sudden you're like, oh man, my calculator's way over there and I'm sitting way over here. Why would you get up to get your calculator when you can just use the calculator app, not app, but website, tool, how about tool, that's online. I don't think that's a bad idea to have that bookmarked. When we are in regular school, I use a computer that's up there so that it works for the overhead screen. And I use two things. I use Desmos, and I also use something called, like, I don't even remember what its name is now, like RF83. Basically, it's just the steel of the TI-83 calculator. And that way, instead of me having to go and get a calculator, more than that, is in class, it's nice when you can actually see the buttons I'm pushing. So then I just use those things to do that. So, you know, consider doing the same thing, please. All right. Whole big tangent was about the calculator. 39.7 divided by 12 is 3.3. Hey, this sounds familiar. I didn't do this already, did I? I won't know because I can't see the chat. So if you're saying, no, we didn't do this one. Ours was 6.6 on this one here. Moles of hydrogen. Man, I'm having a hard time focusing today. I've got lots of energy and just can't focus. 58.5 divided by 35.5. 58.6 really, but it's too late, I already typed it in. 1.65, close enough anyway. Remember that these numbers, even if I had written this correctly with a 6 there, it still would have been something around that. It doesn't matter because these are experimental numbers, often called empirical values. And what we can see here is these two are about the same. And this one here, if you were to divide by 1.65 or 1.7, you would get something around 2. So what that tells us is that our empirical formula is C2H1Cl1. Now, why am I telling you all this and doing the problems out of order? Is because those parts with the percentages have already been done in question number 26. Somebody, you're welcome, it's probably me, already did the work to find out what our empirical formula is. Just like C2H1Cl1 was figured out from all of this math, CH4N was figured out already, okay? Then they tell us what the molar mass is and want us to find the molecular formula. Why I'm telling you all this is because that's all you have to do on the question on your test. On the test, I give the empirical formula, I give the molar mass of the molecule, and I ask you for the molecular formula. So you're already at this step. So you need to know what is the mass of carbon plus 4 hydrogens plus 1 nitrogen. Looks like 30. And then we would say 60 divided by 30 equals 2, which tells us that the multiplier into our empirical formula gives us a molecular formula of C2H8N2. That's all you have to do on your chapter test for this question, which brings us now to 27, where I've already done this part to get us to the empirical formula. So this is what is given on your test, is just C2HCl. You need to then figure out what the molecule is. So we need to know what the mass of this is. 2 carbons is 24. This step right here, you can be just doing this on your, just in your calculator. I don't need to see the work. 1 hydrogen and 1 chlorine is 35.5. In fact, you don't even need to do the work on your calculator. Probably faster to do it from your calculator, but you could also type into your search engine molar mass of C2HCl. Probably will give it. If it doesn't, then you're going to be forced to go to your calculator. 50, I'm going to go with 60.5. So then we take the 181.5 divided by 60.5, and we get a multiplier of 3. So this becomes C6H3Cl3. Check our, just see if there's anything in the chat. All right, so we're all good on questions 26 and 27. Question 28 to finish off this assignment. Methylbutanoate, yesterday, I think yesterday in school terms, they said it smelled like pineapple. Today, they say it smells like apples. Which is the truth? I don't know. I have no idea. but it smells like something. Your textbook in one problem said pineapples and one problem said apples. It's 58.8 grams. Remember, we're going to assume 100 grams so that we can say that it's 58.8 grams of carbon, that it's 9.8 grams of hydrogen. I'm just changing the percentages into grams. 31.4 grams of oxygen. And then we're going to convert those to moles because chemical formulas deal in moles, not in grams. Get out of grams. And get out of grams. Okay, I'm going to have to cheat to the next slide so I can get those numbers. 4.9, 9.8, and 1.9. Perfect. I love those numbers because they didn't come out to be perfectly round numbers. Now, you can go through and divide 1.9 into all of those, and maybe it will divide evenly and give you whole numbers. But do we really need to? Isn't this really close to equaling 5? This is really close to equaling 10, and this is really close to equaling 2. Right there, that tells me that if I write it as C5H10O2, that's already an empirical formula. It doesn't reduce down anymore. So that must be the empirical formula that we have. So then we have to find out the mass of all of this. Like I said, type it into your Google search engine. That will tell you the molar mass of that. Maybe I can do it in my head. 5 carbons, 12 each, is 60, plus 32, 92, plus 10, 102. Okay. Hey, I like that. 102 and 306, they look very similar. 306 divided by 102 equals 3. There's my multiplier. Methyl butanoate must be C15H30O6. I think I did my math right. All right. Well, let's check our work here. There it is. Yeah, somebody even told me, somebody who likes getting extra credit points, doesn't need them, but likes getting them, said, hey, I made a small mistake on number 28. It's supposed to be O6, not CL6. So that was my mistake. Okay. Your review. Now, in a perfect world, for those of you who need to repent of your sins and didn't already do the review ahead of time like I asked you to, what would be perfect would be for us just to pause, right? And then you'd push pause, you'd work out these 3 problems, then you push go and you'd see what I did. But that doesn't work right now because we're all live. So therefore, those few people who already did the assignment are like, well, what am I going to do while you guys are going over those 3 questions? I'm going to sit here clip my toenails, right? Which would be a good idea. Mine need to be clipped, but unfortunately, I'm the one who's got to help. So in a perfect world, you do these ahead of time. That's why I'm sending you the video lesson for the final exam review. That way, if you are a sinner and don't do the review ahead of time, when you do sit down to the video lesson, I'm expecting you to pause and play the entire time until it's done. That would be the best way for you to see how good you are. You want to know how you're going to do on your final? It's not about sitting and listening to me. How you're going to do on your final is about you sitting down and doing the problem first, all right? So like in question number 1, what would you do? I'll wait. I'll give you a moment because, you know, question 1 and 3 are on your test. I mean, different substances, different numbers, but they're on your test. Hey, while we wait, maybe I should cut my toenails. Gross. I cut my toenails outside. That way, when the little foot toenail thing goes flying off, it lands in the dirt anyway, right? You don't clip your toenails inside. That's gross. Little pieces of toenail in there. Or somebody steps on it in their bare feet, embeds itself inside the bottom of their foot. That, number 1, would hurt, and number 2, it's gross. Yeah, I know. It's all right. Nobody probably reads the chat anyway, Ashley, so they wouldn't know. Don't we set it up? Yes, absolutely. Absolutely set it up as a math problem. These questions, like we've always been joking, this whole chapter feels like a math problem. So we start by drawing the line, and then we find a question, how many moles? Then the given that they give us, we'll put that on the first line. I am a firm believer in outthinking the person who writes a test. In other words, you outthinking me. And I don't have a problem if you outthink me, all right? I've spent a lot of time in silent meditation, lowering my ego to be okay with the fact that my students are smarter than I am, okay? I just know more than you do because I'm like 3 times your age, but I know you're smarter than I am. So when I write your test questions, you should be able to outthink me when you're gonna go and solve this. Right away, if you have your choice between periodic table, 22.4, and 6.02 times 10 to the 23rd, wouldn't you already be looking at this and going, oh, this has got to be the 6.02 number, because that's the only time we ever see numbers that are in scientific notation in the given, right? So don't be afraid to outthink it. A lot of you probably don't even need to think about that because it's just kind of second nature at this point, that if you have molecules given as you're given, that you're going to get out of molecules and you're going to get into moles. Okay, and then you already would know that that's the magic number, 6.02 times 10 to the 23rd. Then we do the division, divide those two numbers, and my calculator says 0.249. All right, now it's still sad because the person who asked me the calculator questions concern is not here to hear me say this. But you know what? The rest of us can still benefit from something. There's some very, very smart students in this class. I know all of you are smart, but there's some of you who are maybe have done a little better along the way. And maybe for some reason, yours is the calculator that breaks and you're like, like this is the SAT and you're sitting there going, ah, crap, now what? Come on, you got the math skills to solve this. That if you just needed to use your phone that lacks the scientific notation buttons, right? That lacks the ability to put this in scientific notation properly, 10 to the 23rd power cancels out 10 to the 23rd power. So really all this problem is 1.5 divided by 6.02. My calculator, or my phone calculator, can do that. So sometimes you can kind of see where the answer should be based on the fact that the scientific notations are about the same. If this had been 10 to the 24th, I don't know, I'm getting into this too much. That would just give us times 10 more. So you could do this without a calculator or without a scientific calculator if you had to. Gram formula mass of H3PO4. We've done so many of these, I'm just going to put up the answer for it. You add 3 H's, 1 P, and 4 O's. I'm not expecting to see these on the test because with you taking the test at home, why wouldn't you be using the Google to do this for you? You just type in molar mass of H3PO4, and it's going to give you that 98.0. If you show that step on a conversion table problem and you happen to get the answer wrong, this will get you an extra partial credit point. So your choice. Question number 3 is another good test question. How many moles is 15.5 grams of silicon dioxide? That's basically like beach sand and quartz and all of that is all silicon dioxide. Why does beach sand look different than silicon dioxide? Because you just dope a crystal with just a little bit of other things in there, and all of a sudden you get really, real different properties of the substances. So kind of interesting, but they're all silicon dioxide. How many moles? Sounds like a question. All right, 15.5 grams is the given. All right, savor that. Wow, 15.5 grams. I wonder how many grains of sand that is. Savor it because we're getting out of it. And we're going to go into moles. Then we're going to go to our periodic table. That's where this step comes into just a step along the way in a conversion table problem. 1 silicon plus 2 oxygens, 32 plus around 30, I think, maybe 28, so maybe 60. Hey, look at that, 60.1. and then divide, and we get 0.257. Remember, I am grading significant digits, so this part has to be there. If you don't have the units in the answer, I don't grade that wrong. But if you get the answer wrong, that counts as me assuming that you started with this, right? So if you don't show your unit in the answer and you get it wrong, then that tells me that you didn't write this down first and show me that you knew what the question was. So you wouldn't get that partial credit point. But if you just answer, if you showed your work, now you need to show your work, because if you just give me an answer, I assume foul play. You show your work, you get an answer, and you just have it like this without the units, you'll get full credit. I will be grading significant digits though. 3 significant digits, 3. The majority of the problems on the test are 3 significant digits. But on every form of the test, I tried to give you at least one question on this chapter test that either has 2 or 4, and then one question on your final that either has 4 or 2. So depending on which test I give you, well, how am I going to know? I'm not going to try to give you like the same form for, I'm not that diabolical. I just randomly pick. Here's what I do is I've made a list of who I recognize are friends, right? You guys don't know this, but you give away your friendships by when you turn in labs that are the same, or when your homework assignments get turned in at the same time. So once I know who the friends are, then I know I put a little note there that says if I give this person Form A, I don't give the other person Form A also, right? So that's about the only diabolical things that I have going on. But as far as which form you get, that part is random. Find the mass of 1.5 moles. Hey, these are all nice. They're just 2-step conversion table problems. Mass means grams. C5H12. Some kind of pentene, I think. 1.5 moles. Get out of moles and get into grams. Usually it's the gram step that initiates writing down what the substance is, because that's the step where I actually need to go to my periodic table. Add 5 carbons at 12 each, 60, plus 12 more is 72. 72 times 1.5, 108. Check the... Yeah, see, by now I'm so far behind on the chat, I don't even know what you guys are referring to. Calculate the volume of 7.6 moles of argon at STP. All right, I don't know what this means. Could be a 2-step, could be a 3-step. So I'll just make the line kind of long enough, and then calculate the volume. Sounds like we want volume as an answer. The unit of volume is liters. If you write down volume here, you'll still get that 1 partial credit point. But in order to solve it, we do need it as a unit. The given number here is 7.6 moles of argon. Looks like this is just going to be a 2-step equation, because we're already going to get out of the moles in step 2, and we're going to get into the liters with step 2. And because it's at STP, that's a dead giveaway. Whenever you see STP, 22.4. Whenever you see liters, 22.4. Multiply those two numbers. All right, let's talk about trick questions and me trying not to do this. I made the keys ahead of time because I didn't want things like this to happen. If you have a question that has 2 significant digits like 7.6, let me just type this in so I can see, because I bet you that's not exactly 170. Clear. 7.6 times 22.4 is 170.24. This is what your calculator says. Okay, you need to round that to 2 significant digits. So we're going to cut this off right here. But you can't remove that 0, because then 170 becomes 17. So therefore what we have to do is we just keep it, but we keep it as a 0. I tried, I don't know. I think I did my best to avoid those kinds of situations, because I hate when zeros come up in answers on calculators, because then we get confused on significant digits. I'd rather you be able to figure it out pretty easily. But like I said, some of you on your test will get 2 significant digits in a problem. So be ready. Question number 6, find the volume of 835 grams of SO3 at STP. Make a long line in case it's a 3-stepper. Maybe you should try it this one if you haven't done your review yet. While you're trying it, I'll just look at the, oh my gosh, we just had a bunch of stuff popped up in the chat. So I'm going to read all of these things in the chat, and while I'm reading these things in the chat, then you can be working on question number 6. So you know what you said that you used the number when dealing with problems that involve scientific notation. I was wondering if we were ever going to use that equation when dealing with something other than scientific notation. If I can understand your question about the 6.02, so this is what I've been asked. I will get to the messages below hopefully in a second. When you see 6.02 times 10 to the 23rd, are those the only problems that involve scientific notation? Yes. On this chapter test, the only problems that could have scientific notation in them are these. Now, they don't have to be that way, right? I could ask question number 6. I could have said, find the volume of 8.35 times 10 to the second grams. Grams, right? And that would involve scientific notation, but not use 6.02 times 10 to the 23rd, because we don't need that in this problem. So it is possible, but it is not possible on the chapter 10 test because I did not write any problems like that, okay? So the only time that when you see scientific notation, you know you're going to be using that number at some point during the problem is a true statement on your chapter 10 test. On your final exam, it's not. The reason why is because in your final exam, there's a question that looks like this. That uses scientific notation. That has nothing to do with Avogadro's number. That has to do with the wavelength and frequency of electromagnetic radiation from chapter 5. So this is the only other time that scientific notation shows up on your final. And this is the only time that scientific notation shows up on your chapter 10 test. That was a very good question because that shows you outthinking your teacher. Okay, so that was that. Now keep working on number 6. For those of you who are working, I'm still reading. Oh, okay, we're talking about Richard and Allison, same test. You know, only time that I recognized you guys ever in possible friendship has been in the chat when you guys have been saying things to each other. I have not noticed that on paper. So therefore you are not on a list here as 2 people. So you could end up with the same test. And since I'm in the middle of my Zoom right now, I don't have time to write that down. So I still won't. You guys are mean. You must have already dated or something. Hey, you know what, Allison, I don't care if you were a he or a she. If I ever refer to you, I'm always going to say they, because that way, however you identify is your choice, and it does not ever, ever bother me. Okay, so now back to the question about the person who said the 6.02. You have to elaborate on what do you mean by why wouldn't you use 6.02? What does that mean? Like, why wouldn't you just put in 6.02 and just exclude the times 10 to the 23rd? Because that's the rules. You can't do that. It's always Avogadro's number is this number. 25 new messages. Stop blowing up my chat here. I can't keep up with this. Trying to answer important questions and you guys are just going at each other the whole time here. Why don't you just unmute and yell at each other so that I can just keep answering the questions here. Never dated her. Well, that tells me it probably did. Okay, no, I was asking that when you were, oh, okay, so therefore you're good. I can take that as you're good now. 30 new messages. All right, already. Good. You know what? Those of you who are saying that you always use theys and thems now too, while we're talking about a very small percentage of people that actually do identify with theys and thems, it's still somebody. So therefore we just do it because it's just being nice, right? It's sometimes nice in life just to be nice for the sake of being nice. You're walking by somebody in a store and you're not paying attention, you guys bump into each other and a person says, hey, watch it. And you turn and you go, I'm sorry, right? Isn't it just nice sometimes just to be nice, right? Life would be so much easier if we were all just nice. I think I got to the bottom of our messages, good. And you guys seem to agree with me. So see, it would be great to be in class together right now. I think I answered the question I needed to, so therefore I'm going to go back to question number 6. Hopefully those of you who were working on it are feeling happy about it. Find the volume means liters. You're given 835 grams of SO3. Savor it. If you don't know what it is, it smells like rotten eggs. It smells like a fart. Why? It's your nose, right? Your nose has certain receptors that it remembers what different things smell like. So does SO3 really smell like a fart? Or is it the fact that a fart has small particles of feces in it along with SO3 that then makes you think that SO3 smells like a fart, all right? Now, I know it's kind of a weird conversation to have, but it's very biological and very chemistry related, all right? So anyway, regardless, you savored it for a moment. We had a good biological discussion. You can go back and ask Miss Amaro what she thinks about what they think about the sensory nerves inside of our nose, olfactory nose or olfactory sensors, something like that. 32.1 plus 48, 80.1. How about, since we haven't done this in a while, we'll just do one. 1 sulfur at 32.1 is 32.1. 3 oxygens at 16 each is 48. Add those two numbers together, 80.1, that's a 1, grams per mole, okay? The number always follows the grams. A 1 always goes with the moles. Remember us saying that some of the first days of this chapter? I'm going to repeat that sentence. The number always goes with the grams, and the 1 always goes with the moles. So if the grams go on the bottom, the number goes on the bottom. Now we're out of grams into moles. Now we're going to get out of moles, and we're going to get into liters. Okay? And then math. Multiply top numbers, divide by the bottom number. Significant digits, 3. Number 7. Already the percent composition. Man, this must jump around. Calculate the percent composition. You have one of these on your test. So they give us the formula. I'm going to say the molecular formula. I don't know. Let's call it the chemical formula. That's a little bit more general. And because we don't know if it's empirical, molecular, but really hydrogen sulfide really probably should be considered just more like an ionic bond and therefore call it a chemical formula. Doesn't matter. There's 2 hydrogens at 1 each is 2.0. There's 1 sulfur at 32.1 is 32.1. Add those together and get 34.1. Now, how this works on your test is I'm not going to ask you for both elements. I'm just going to ask you for one. So if you get this question, it'll say find the percent composition of hydrogen in hydrogen sulfide. You would then say that there are 2 divided by 34 and then times that by 100%. And then the other one, you'd say 32 divided by 34 times 100%. I got those percentages. Now you'll notice these are percentages, which means that just like question number 8, finding the percent composition is really the backwards problem of finding the empirical formula given the percent composition. It's just the problem is they don't look backwards of each other when you see the 2 things worked out, right? So you can't just like take one and run it in reverse to find the other one. The procedure does look a little bit different, but in the end, the essence of these two problems is the questions are in reverse. We assume 100 grams so that we can say 65.2 grams of scandium and 34.8 grams of oxygen. Get out of grams, get into moles. Get out of grams, get into moles. I know this one, 16.0, but I don't know scandium. I have to look on my periodic table, 45.0. And then we divide. I'm going to have to keep looking over here. 1.45 and 2.17. Oh, this is a great one. Oh, I'm so glad I gave you this one. 2.17. You know why I'm happy I gave you this one? Because when you look at this problem, you might go, well, the problem is if you divide both of these by 1.45, of course that comes out to 1, but the other one, 2.17 divided by 1.45 comes out to be 1.496. Well, I mean, I guess that does come out to be 1.5. On a test, that means you need to times both of these times 2, which means that it becomes scandium 2, oxygen 3. But I would give you full credit if you told me scandium 1, oxygen 1, or if you told me scandium 1, oxygen 2. Because the fact that this is right in the middle, AP test allows that, I'm going to allow that too. It doesn't happen on your test. On your test, the numbers work out to be very close to whole numbers the whole way through, so nobody has that issue. No, it doesn't even happen on your test anyway, because I already told you that I've given you the empirical formula, and then you have to find out what the molecule is. So you don't even have to do this on a test. I'm telling lies, right? I'm telling you stories that aren't true, because this isn't on the distance learning test. It's only on the in-class test. So all you have to do is the molecular formula, which is what number 9 is doing. All right, I'll do this part real quick. Let's do this in red because you won't have to do this. 94.1 grams of oxygen, get out of grams of oxygen, get into moles of oxygen, equals probably 5.9. And then 5.9 grams of hydrogen at 1.0 also equals 5.9. Mole H and mole O. So they're the same. Because they're the same, that tells us the empirical formula is HO for Christmas. And then this is the empirical formula, right? So on your test, this is what it says. The empirical formula of a substance is H1O1. The molecule has a mass of 34 grams per mole. What is the molecular formula? So 1H plus 1O adds up to 17.0 grams per mole, right? Just add the two together. 34, sorry, I'm supposed to switch to a different color now because from here on, this is what's actually on the test. 34 divided by 17 equals 2. So that tells us that our chemical formula, molecular formula, is H2O2, hydrogen peroxide. Almost done, 3 more questions. How many molecules are in 97.3 grams of potassium oxide? That is on your test, so let me give you time to solve that one. I'll see if I can get caught up on the chat. How many questions are on the test? We'll talk about that in a moment. Let's see what else I got here. Preach, I saw that one. Thanks, Allison, I appreciate that. I didn't even know what he put, so hopefully he didn't put anything mean. What's the difference between honors chemistry and AP chemistry? A little and a lot. Now, I can tell you that last year in AP chemistry, Maria Eagleton had 110% when the year ended. This year, end of first semester, Maria Eagleton has 110% in AP chemistry. Last year, I can tell you that a kid named Nate had something in probably the 70% range as his grade in honors chemistry. And right now, Nate has something in the 70% in AP chemistry. What does that tell you? You will step up to the level change, right? You learn chemistry here, you build on it there, but you also are getting better as the chemistry is getting harder, such that your grade should stay the same. So what's different? We learn the same chemistry, we might go a little deeper with some topics. So there are some things that we need to see more. See, normally if we're having this conversation, we've already gotten through chapter 12, and then we really kind of know what's going on in the hardest chapter of chemistry, is chapter 12. So what's the difference? Just depth of everything that's here. We have to cover some things second semester that we never cover in honors chemistry. It gets harder, but you can keep up with it. Now, the only reason I'm telling you this right now is because it shouldn't be too long till they start hitting you up for classes for next year. I'm a kind of person who wants to include everybody. So if you want to take AP chemistry and you're not sure, email me and I'll look at your grade in the class and I'll tell you straight up whether or not it's a good idea. What I usually try to do is I try to talk to my honors chemistry students. If you are struggling or you're lazy, then you should take regular physics. If you're not struggling and this class has been pretty easy for you so far, then you should take AP chemistry. If you think that taking AP chemistry next year, that means your senior year, you're done with science, then I say don't take AP chemistry, take physics. Because when you sign up for college, a college is going to look at your classes you took in high school and say, why did a student take honors bio, honors chemistry, AP chemistry, and then stop taking science? You're a red flag that says this student has now become a flake, right? They're not challenging themselves. So they're going to pick somebody over you. Unless they have nobody else to pick, then they'll pick you, right? So a college wants to see that you took the big three: biology, chemistry, physics. So if you're going to stop after next year, take physics. If you think you're going to take all 4 years of science and you're doing decently in here and you feel like, yeah, you know what, I can't wait to hang out with Mr. Purser in person, then take AP chemistry and then you'll take AP physics your senior year. I've had 25 to 35 students per year do this for the last 4 years. So, you know, it's not like you're going to be the first person ever pioneering having to take all of these hard classes. Many students do it and that's just fine. But I do have some that get into AP chemistry and then realize they hate chemistry and then they quit taking science altogether. And that's not good. Colleges don't like to see that you didn't take physics. So then I would suggest taking the physics instead. Can you take them both at the same time? I've had students that do that too. Talk to me in an email and I can tell you more about that because I shouldn't be wasting your time with this right now. How many questions are on the test? This one, I think I said there's 7. Final exam has 23. How many molecules are in there in 97.3 grams potassium oxide? Hey, this is a chance for us to talk about what do you do if you don't know? How many molecules? I can't even tell you how important a skill it is. Hey, back to AP. How important a skill it is in an AP class to continue working with something when you don't know something early on. So when you have 97.3 grams of potassium oxide and you have no idea what potassium oxide is, you have to make it up. You know that potassium oxide, you have a periodic table, so you can't at least tell the teacher, tell the AP grader that it has something to do with K and O. So you just put, now don't write this down exactly because this is not done. It has something to do with KO, right? Potassium oxide. So you're going to get out of grams of this KO and you're going to get into moles of this KO. We know a 1 goes there. Now, if you add 1 potassium plus 1 oxygen, look at me looking all over the place. You know why? Because I'm getting to the point where I can't even see the periodic table much anymore. 39.1 plus 16. Let's try that. 39.1 plus 16 is 55.1. This is not the right answer. So if you're copying this down, you're copying a waste of time. 55.1. Then we've gotten out of grams. Now we're going to get out of moles of this KO. and we're going to go into molecules. Technically, it's not a molecule, it's a formula unit, but we'll just call it a molecule. Now, we know that molecules is 6.02 times 10 to the 23rd, no matter what it is. So that part's correct, so we can write that one down. You solve this out, and you get the answer, 97.3 divided by that number, then times 6.02, 23, and you get 1.06 times 10 to the 24th, which is not right. Significant digits, I'm going to go with 3, 1.06 times 10 to the 24th. And this is worth 8 points as a test question because it's a 3-step conversion table. I'm going to give you 7 out of 8. You don't even have the right substance, and you got 7 out of 8 points. With these zooms and with the curve, you've got over 100%. So here's the moral of the story. Just because you look at this and you're like, I don't know what potassium oxide is, you can't quit. You have to work the problem out. You can write me a note. Put a little note there. Put it inside of a heart that says, I am so sorry, Mr. Purser. I do not know what potassium oxide is, so I'm just going to make it up. I'm going to pretend that it's 10. And then you solve it. And you get 7 out of 8. Okay? AP test works that way too. Now, the true formula for potassium oxide is actually K2O. Why? Well, it has to do with that whole crisscrossing the oxidation numbers thing, right? Now, you guys don't also have, you have a special situation in that you were taking the test at home, which means that you can actually type into Google, hey, what's potassium oxide? While you're at it, can you also tell me the molar mass, right? So then you don't have to go through all of this hassle. So there is no reason why you shouldn't know the substance, but let's use that as a metaphor for whatever problem you might have on a test question. The metaphor is you cannot quit. You have to take it as far as you can and then take it further. Put a bunch of stuff there that's not right, because if there's any part of what's not right there, I will give partial credit to the parts that are correct, along with the stuff that was correct up to that point. So show me all the work. K2O all the way through. Do I have an answer slide? I bet I do. How about that number instead? Okay, questions 11 and 12, and then we're all done. I'm going to leave it there for number 11 for a moment. I'm all caught up on the chats. Nice. Feels like a math problem. What is the volume of neon? 28.0 grams of neon. Savor it. Like, I wonder how much neon that is. Like in a neon sign, how many grams of neon are in there? I don't know. I'm just a chemistry teacher, right? If I knew those kinds of things, I'd be teaching at UCLA. Why would I be teaching in the high desert? Living in the high desert. I could live in Brentwood. Just kidding. You know who knows how many grams of neon are inside of a neon sign? A neon sign maker, right? A chemist doesn't know that. They could estimate, but the problem is they would ask a bunch of questions first, because the first thing that I would ask is, what's the pressure of the neon inside the tank, inside the sign? Because if it's at standard atmospheric pressure, my guess would be there'd probably be less than, I would probably say that less than 0.1 grams of neon in a sign. But if it's at a high pressure, then it could be more. Well, not just could be, it would be more. So we'd have to know a little bit more. So that's what a chemist would have to ask, but it's still something we can ponder because I'm savoring it. 28 grams. Neon's like around 10. No, it's not. It's around 20. 20.2. Last step, get out of moles of neon and get into liters. Should have said at STP. See, now once you put it at STP, now I know it's not a neon sign. Well, I don't know it's not a neon sign because I don't know the pressure of neon inside of a neon sign. I just got through saying that. We'd have to go look that up. I bet Google knows. I bet you know who knows that TV show How It's Made. What a wonderful TV show to fall asleep to. You know, I go upstairs, go lay down, put on Discovery Channel, and I see that it's How It's Made or the Cosmos or something like that, I'm like, all right, now I know I'm going to sleep well. And sure enough, I have to set the timer because it's not going to take more than 10 minutes, and I'm out cold. So it's okay. They re-air the episode, so if I go to sleep at different times, you know, I catch the different 10 minutes here and there till I'm all caught up. Do some math. 31 liters. Obviously, a neon sign is not 31 liters. 31 liters is like the size of a big, not a big, but like a normal size aquarium. Those rectangular aquariums are probably around 30 liters. A lab group finds that when magnesium combines with oxygen, this question is very pertinent when we're back in school because we do this experiment. We will do this experiment. With oxygen to form a compound, the percent composition is 60.3 and 39.7. What is the empirical formula of this compound? All right, when you see percentages, you know immediately, call those grams. Now, you don't even have to do this on the test. So at this point, if you want to start checking out, you can, unless you're going to have a question. I only have one more slide, so we know that's just going to be an answer slide. And on your test, we're only doing the next step. So don't check out yet, because you should at least see the next step. Magnesium, I can see it bigger here, 24.3. And then same thing with oxygen, 39.7 grams of oxygen and 16.0 grams of oxygen per mole. I don't know, calculator would give me those two values. 2.48 for each of them, wow. Hey, that tells us they're in a 1-to-1 ratio. So the formula for magnesium oxide must be MgO, which it is. You could verify that by magnesium coming from column 2. Remember, this is final exam stuff now. Column 2 plus 2, oxygen. Column 16, -2, crisscross oxidation numbers, and reduce it down to MgO. All right, that's all I got. I'm going to turn off the share, or the record, I mean.